Hello, good day. I am Elizar Sapinoro, Visa A5, and I am a member of Group 6. And for this video, we will present to you what is basin irrigation. So, first, irrigation is the method in which water is artificially supplied to plants at regular intervals for agriculture. Irrigation is used to assist in the growing of agricultural crops, maintenance of landscapes, and revegetation of disturbed soils in dry areas, and during periods of inadequate rainfall. So irrigation has been a central feature of agriculture for over 5,000 years and is the product of many cultures. It was the basis for economies and societies across the globe, from Asia to the southwestern United States. Irrigation was used as a means of manipulation of water in the alluvial plains of the Indus Valley civilization. The application of it is estimated to have begun around 4500 BC and drastically increased the size and prosperity of their agriculture settlements. The Indus Valley civilization developed sophisticated irrigation and water storage systems, including artificial reservoir at Gernar dated to 3000 BCE and an early canal irrigation systems for 2600 BCE. Large-scale agriculture was practiced with an extensive network of canal used for the purpose irrigation. Surface irrigation is the oldest form of irrigation and has been used for thousands of years. In surface irrigation systems, water moves across the surface of an agricultural land in order to wet it and infiltrate into the soil. Surface irrigation can be subdivided into furrow, border strip, and basin irrigation. It is often called flooding irrigation when the irrigation results in flooding or near flooding of the cultivated land. This has been the most common method irrigation agricultural land and is still used in most parts of the world, where water levels from the irrigation source permit. The levels are controlled by the dikes, usually plugged by soil. This is often seen in terraced rice fields where the method is used to flood or control the level of water in each distinct field. In some cases, the water is pumped or lifted by a human or animal power to level of the land. The water application efficiency of surface irrigation is typically lower than other forms of irrigation. Basin irrigation is defined as the application of water to an area typically leveled to zero slope and surrounded by dikes or check banks to prevent runoff. Basins are formed by constructing bands surrounding the flat areas to prevent water from flow to adjacent field. This method is most applicable to crops like paddy, where requires standing water in the field. In general, the basin method is suitable for crops that are unaffected by standing water for long periods. 12 to 24 hours. Bunds can be constructed on flat and terrace lands. Basins are flat areas of land surrounded by low bands which prevent the water from flowing to the adjacent fields. Basin irrigation is one of the most popular types of on-farm surface irrigation, in which water application can achieve high uniformity. It is used for crops planted on beds, furrows, corrugations, or on the flat. These types of system has become common due to the ability to reduce runoff and lower labor. So, as I've said, the basin irrigation is one of the oldest irrigation system that we are using until these days, because here in our country, irrigation is one of the biggest problem of our local farmers.
Good day, I am Jesse Sotelo and I am going to talk about design aspects. Basin layout. Basin layout not only refers to the shape and size of the basins, but also to the shape and size of the bunds. What is the shape of the basin? Square, rectangular, or irregular? How high should be the bund? 10, 50, or 100 centimeter? What is the shape of the bund? Shape and size of basins. Basin width. Main limitation of basin width is the land slope. Steep slope than narrow basins. Factors affect basins width. Number 1. Depth of fertility soil. 2. Method of basin construction. 3. Agricultural practices. Here is a table of approximate values for the maximum basin or terrace width in meters. The maximum width depends on the slope percentage. For example, 0.2% of slope, the average is 45 meters, and the range starting from 35 meters to 55 meters in maximum. 0.3 slope percentage is 37 in average, and the range is starting to 30 to 45 meters, and so on. Follow the slope percentage to get the maximum width of basin or terrace width. Basin size. Main limitation of basin width is land slope, steep slope, then narrow basins. Factors affect water flow to the basin. 1 is soil type, 2 available water flow to the basin, and 3 the land slope. Here is table 2 for suggested maximum basin areas for various soil types and available stream sizes. What is bunds? Bunds are earth embankments which contain irrigation water within basins. They are sometimes called ridges, dikes, or leaves. The height is governed by irrigation depth or freeboard. Temporary bunds are normally 60 to 120 cm wide at the base and have a height of 1.5 to 30 centimeters above the original ground surface, including a freeboard of 10 cm, which means an irrigation depth of 5 to 20 cm. Temporary bunds surrounds fields on which annual crops are grown. These bunds are built each season. Permanent bonds usually have a base width of 130 to 160 cm and a height of 60 to 90 cm when constructed. The settled height will be 40 to 50 cm. This setting, compaction of the soil will take several months. Permanent bonds are mostly used in rice cultivation, where the same crop is planted on the same fields year after year. The bonds are used as paths in the rice field as well. Temporary bonds may be used to subdivide the various fields further. There are criteria to be considered in designing basin irrigation. First, topography. The basin shall be nearly if not completely level to prevent tailwater. A difference of 6 centimeter to 9 centimeter between the highest and lowest elevations may be allowed such that it is less than one half of the net depth of application. Soil type. Sandy soils or fine textured soils that crack when dry should be avoided to maintain adequate basin ridge height. Application rate. Irrigation water shall be applied at a rate that will advance over the basin in a fraction of the infiltration time. Irrigation volume. The volume of water applied shall be equal to the average gross irrigation application. Intake opportunity time. The intake opportunity time at all points in the basin shall be greater than or equal to the time required for the net irrigation to infiltrate the soil. Design application efficiency. The minimum design application efficiency shall be 70%, thus the minimum required to cover the basin shall be 60% of the time required for the net application depth of soil infiltrate. Basin dikes. Top width of the basin dike shall be greater than or equal to the height of the dike. Supply ditches. Supply ditches shall convey the design inflow rate of each basin's or multiples of the design flow rate where more than one basin is irrigatedly simultaneously. Outlet location. One outlet shall be installed for basins widths up to 60 meter and flow rates of up to 0. per cubic meter per second. Drainage. Surface drainage facilities shall be provided for basins with low or moderate intake soils and in high rainfall areas. Erosion. The maximum water flow velocity into the basin shall be less than or equal to 1 meter per second to avoid scoring and erosion. And last, agricultural practice. The width of the agricultural machinery or implement to be used in the basin shall be considered in finalizing the width.
Hi, I'm Ruby Joyce Pitongpalan. Now I will talk about the design principles and the design steps or the methodology of the basin irrigation system. First, let's talk about the design principles of the basin irrigation. Basin irrigation is a class of surface irrigation methods in which area is divided into basins. Basin irrigation systems has similarity to border irrigation. They are both involve a uniform sheet of water flowing over the soil, but they has a difference in applying water. Basin irrigation involves applying water to nearly level field and may include ponding for extended time periods. While border irrigation, water flows between dikes that divide a sloping into rectangular strips with free drainage at the end. The purpose of dikes is to contain water as it flows across the field. unlike basin irrigation where the dikes pond the water. Now, as you can see in the figure, it shows the water supply ditch, water flow, the dike, the level, and the slope. The divided field into smaller areas or the rectangular strips are called basins, so that each has a nearly leveled surface. Bands or the dikes are constructed around the area's farming basins within which the irrigation water can be controlled. The basins are filled to the desired depth and the water is retained until it infiltrates into the soil, particularly in irrigating rice. Basin irrigation method is similar to free flooding method except the water is controlled by surrounding the basin area with low and flat level. There are two methods to supply irrigation water to basins. First is the direct method and the second is the cascade method. The direct method, irrigation water is led directly from the field channel into the basin. It can be through siphons, in piles, or band breaks. As you can see in the figure, it shows that the basin A is irrigated first, then next is the basin B, and so on. This method can be used for most crop types and it is suitable for most soils. Next is the cascade method. On sloping land where terraces are used, the irrigation water is supplied to the highest terrace and then allowed to flow to a lower terrace and so on. As you can see in the figure, it shows that the water is supplied to the highest terrace, which is A1, and it is allowed to flow through terrace A2 until the lowest terrace A3 is filled. The intake of terrace A1 is closed and then the irrigation water is diverted to terrace B1 until B1, B2, and B3 are filled. Cascade method of water supply. This is a good method to use for paddy rice on clay soils where percolation and seepage losses are low. However, for other crops on sandy or loamy soils, percolation losses can be excessive while water is flowing through the upper terraces to irrigate the lower ones. This problem can be overcome by using the barrow furrow as a small channel to take water to the lower terrace. The lower terrace is irrigated first and when complete the bands is closed, and water is diverted into the next terrace. Thus, the terrace nearest the supply channel is the last to be irrigated. When long cascades are used for growing rice, it is common practice to allow water to flow continuously into the terraces at low discharge rates. The water demand in the cascade can easily be monitored by observing the drainage flow. If there is no drainage, then more water may be required at the top of the cascade. If there is a drainage flow, then it is possible to reduce the inflow. Wetting patterns. Wetting patterns is very important for good crop growth because it helps to give the right quantity of water supply to the root zone and that the root zone is wetted uniformly. If crops receive too little water, they will suffer from drought stress and yield may be reduced. If they receive too much water, then water is lost through deep percolation and especially on clay soils. Permanent pools may form causing the plants to drown. Ideal wetting pattern. To obtain a uniformly wetted root zone, the surface of the basin must be leveled and the irrigation water must be applied quickly. Ideal wetting pattern. The basin is leveled and the right quantity of water has been supplied with the correct scrim size. As can be seen from the figure, it is not possible to have the wetting pattern and root zone coincide completely. The part of the basin near the filled channel is always in contact with the irrigation water longer than the opposite side of the basin. Therefore, percolation losses will occur near the filled channel if sufficient water is supplied to the opposite side of the basin. In poor wetting patterns can be caused by unfavorable natural conditions, poor layout, and poor management. Under the unfavorable natural conditions, it has an example of a compacted subsoil layer or different soil types within one basin. A compacted subsoil layer can sometimes occur in the basin some 30 to 50 cm below the soil surface. Infiltration through this layer may be very slow and so water tends to accumulate above this layer. A perch water table is formed in the figure. This may result in waterlogging.
Basin irrigation is one of the surface irrigation method and one of the oldest method of irrigation. Basin irrigation, where the field is divided into a number of terraced rectangular bays. Look at the rectangular fields. Water is applied and distributed over the soil surface by gravity. Here fields are small areas having level surfaces that are surrounded by earth banks. Observe the field. It is divided into a number of terraced rectangular bays. In this, farmers dig small canals from tank to fields to supply water. And also, provision should be made for the draining the excess amount of water from one field to another field. Look at the outlet of this basin. For uniform supply of water and nutrients, soil should be prepared well. For this, plugging and leveling are done. These systems of irrigation are common, used in where the wheat and rice are grown. Water distribution is uncontrolled in this method, and therefore this is inherently inefficient method.
Okay, now I will talk about the design steps or the methodology of basin irrigation. The design procedure will shown in Table 4 provides a guideline in determining maximum border dimensions based on field experience, and in Figure 6 shows the design procedure. As you can see in the Figure 6, design procedure for border irrigation design, it shows the water supply flow rate and soil type, the slope and the maximum border width and the maximum border length. In Table 4, suggested maximum border lengths and widths. Under the soil type, there is the sand, the infiltration rate greater than 25 mm per hour, the loam, the infiltration rate of the 10 to 25 mm per hour, and the clay, and last is the infiltration rate of less than 10 mm per hour. In each soil type, they has their own border slope, stream flow, border width, and border length. The following steps are involved in the construction of basins. First is setting out, second is forming the bands, and last is the smoothing the land within the basins. Step 1. Setting out. Before construction can begin, the location of the basins and bands must be set out on the ground. This can be done using pegs, string lines, or chalk powder to mark the lines of the bands. As you can see in the figure, setting out is relatively simple and involves only straight lines. On flatland, basins may be square or rectangular in shape. On sloping or undulating land, basins may be irregular in shape and terracing required. Terraces are set up so that the bands are located along contour lines. The differences in elevation within each basin should not be excessive so that the amount of earth movement required to obtain a level land surface is small. Basins should be small if the first is slope of the land is high, second is soil is highly permeable or sandy, third is inflow stream is small in size, and next is required depth of the irrigation is small, and last is the field preparation is done by hand or animal traction. Next is basins can be large if the slope of the land is gentle or flat, and soil has low infiltration rate or inflow stream is large in size, and required depth of the irrigation application is large, and last is the field preparation and intercultural operations are mechanized. Step 2. Forming the bands. Both temporary and permanent bands can be formed by hand labor or by animal or tractor-powered equipment. When soil is gathered from an area close to the band, a barrow furrow is formed. This furrow can be smoothed out later or be used as a farm channel or drain. When forming bands for terraces, soil should only be taken from the uphill side of the band. Bands form an important part of any basin. Bands are small earthen borders which contain the irrigation water within the basin. The height of the band is determined by the depth of the irrigation to be maintained within the basin. A useful piece of equipment for farming bands is an A-frame. You can see in the figure, so This consists of two boards set on edge and cross-braced with a wide opening at the front and a narrow opening at the rear. The boards act as blades for cutting into the soil and crowding it into a ridge or a band. As you can see in the figure, a typical A-frame suitable for drawing by animals has blades 20 cm deep and 2 meter long spaced 1.5 meter apart at the front and 30 cm apart at the rear. Before forming bands with an A-frame, it is useful to loosen the topsoil to a depth of 10 to 15 cm so that the blades can easily collect sufficient soil. Whichever method is used, it is important that the bands are properly compacted so that leakage cannot occur. Last step is the smoothing the land. This can be the most difficult part of basin construction and involves very careful leveling of the land within each basin. On flat land, this involves smoothing out the minor high and low spots so that the differences in level are less than 3 cm. This can be done by hand or by a tractor-drawn land plane depending on the size of the basin. However, 3 cm level differences are almost impossible to judge by eye, and only when applying water will it become obvious where high and low spots still exist. Thus, several attempts may be required to correct the leveling. On sloping land where terraces are constructed, leveling is achieved by moving soil from the upper part of the slope to the lower part, as you can see in the figure. Care is needed when filling in the furrow to ensure the band height is maintained so that the overtopping is avoided.
Hello, good day. So, my name is Benji Ditangonan, Bisa E5. So, we will discuss the basin irrigation and every part of this design. So, this is our own design of basin irrigation. Basin irrigation is one of the surface irrigation method and one of the oldest method of irrigation. Basin irrigation, where the field is divided into a number of terraced rectangular bays which are graded level or have no significant slope. Water is applied to the first bay, usually the highest in elevation, which is the terrace A1, and the next the terrace A2. And when the desired depth is applied, water is permitted to drain back off that bay and flow to the next bay, which is at a lower elevation than the first. So each bay is irrigated in turn using a combination of drainage water from the previous bay and continuing inflow from the supply channel. Successful operation of these systems is reliant on a sufficient elevation drop between successive bays. So, the shape and dimensions of bands. Bands are small earth embankments which contain irrigation water within basins. They are sometimes called ridges, dikes, or leaves. The height of bands is determined by the irrigation depth and the freeboard. The freeboard is the height above the irrigation depth to be sure that water will not overtop the band. So, the width of bands should be such that leakage will not occur. and that they are stable. The temporary bands are normally 60 to 120 centimeters wide at the base and have a height of 1.5 to 30 centimeter above the original ground surface. And while the permanent bands usually have base width of 130 to 160 centimeters, and the settled height will be 40 to 50 centimeters. So the dimensions of our terrace are 25 meters of width and 30 meters of length. So that is our design of basin irrigation. Thank you.